Good job. To become stable. Good. To become stable. And in chemistry, there's a term that I want you to think. When you think stability, I want you to think this. All right, good. Complete octet. That's the second one. Good job.
Where's an octet? Because I keep saying octet.
Octet. Octet. Complete octet. That means 8 valence electrons. To become stable, I'm just going to give it to you. It means low energy. Low energy is good in chemistry. That means stable, stability. High energy, not stable. So radiation, that's high energy. Okay? High energy particles. That's the opposite of stable. One more, another way to say this. Full valence shell, very good. So these are terms we've already learned, and I do that on purpose, so when we get to this unit, it's not all brand new. You've already kind of learned this, okay? How many valence electrons does group 1 have? 1. If they lose that 1, then it has 8. And then group 17, how many valence electrons? 7. If it gains 1 electron,
8.
All right? So they gain and lose or share electrons through bonding, okay? So that's what it's all about. So that's really important to, I think, understand why we're learning this, okay? Besides the fact you're in school, in class, taking a regents, you got all that. This is really what's going on with bonding. This is why anything reacts, okay? All right, let's go over the homework now. I just wanted to make sure we got that down first thing. I'm going to call on random people. You tell me, ionic, covalent, or both. Take out table E. We're going to need that, table E. Okay. Number 1, oh wait, we did 1 and 2, didn't we? Yeah, okay. 1 is ionic, 2 is covalent. Remember, ionic is metal, non-metal, and covalent is 2 non-metal. So all you got to be able to do is identify where they are on the chart. All right. Here's the tricky one. Olivia, 3. Very good. Sometimes students want to tell me that's ionic and they're wrong. Why? Right, hydrogen is a non-metal, but look where it is. It's over here with all the metals, but remember it's there because it has 1 valence electron and 1 proton. That's why it starts the whole periodic table. But hydrogen is a non-metal, and so is oxygen, so that is covalent. H2O is covalent for sure. And that's good, because water is a certain type of covalent, which is why there's a lot of it in our body and on the planet. If it was a different type of bond, then things would be very different. 4, BaSO4, Caitlin. Both, very good. Tell me why.
Because Ba is a non-metal.
Try again.
Is a metal.
Good. Ba is a metal.
S and O are non-metals.
Right. So between the Ba and the S, there's your ionic, and then between the S and the O, here's your covalent. So it has both types: metal, non-metal, and then non-metal, non-metal. So that's both. 4 is both. What polyatomic ion, Kristen, does number 4 have? What polyatomic ion? Everyone should be looking at this on their own. She's just going to answer it. What polyatomic ion does number 4 have? I'd like the name, please. You want some help? Sulfate. Is that what you're saying? Or no? What did you say? I didn't hear you. Oh, thiosulfate? Well, if you look at the formula for thiosulfate, what is it? S2O3, right? So we don't have S2O3. We have SO4. So find SO4 on table E, and what is it called? Sulfate, right. So this is new, all right? It's new to Kristen, new to everybody. So I want you to start to be able to use table E, be able to find the ions, because that's important moving forward. So you look at it, Ba is obviously up here. Ba is on the periodic table, so that's not on table E. You're looking for the SO4. That's what you're looking for. So you'll get better at it. Everybody will. The more you see it, the more we look at it, you'll be good. That's not something I really actually give notes or teach necessarily. We just use it by practicing. 5, K2O. Nick. Ionic, metal, non-metal. Very good. 6, Riley. Ionic, metal, non-metal. Good. Na is a metal, F is a non-metal. Ionic. 7, Jake. Both. So just like BaSO4, we have Na2CO3. Again, look up here, please. Metal, non-metal, there's your ionic part. Metal, non-metal, 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 that's your covalent part. So it has both. Okay, which polyatomic ion, Autumn? This 7 had. Which polyatomic ion? It's not Na, because that's on the periodic table. So you're looking for the other ones.
The CO one?
Yep.
Yeah.
Carbonate, very good. CO3 minus 2, that's carbonate. Good, good. CH4, number 8, Willow.
Number 8 is covalent.
Covalent, very good. Sam, 9, SO3. Covalent, 2 nonmetals, good. Just like number 8, 2 nonmetals, good. LIBR, Annika. Ionic, very good. Before we move on here, someone tell me, how do you know to look on table E? So in other words, look at number 4, look at number 7. How are they different than all the other ones in that first column there? 1 through 10, look at 4 and 7. How do they look different to you? Structurally, how do they look different? I don't know if that makes sense to you.
Is it because the capital letters and the lowercase ones?
Say that again, the capital.
There's like only 2 of them, right?
Only 2 what?
Those things, those 2.
2 elements where?
There's only 2 elements in that.
In which
Number
one?
10.
In number 10?
Well, you said look at.
Very good. She's she's good.
Right?
Number 10, there's only 2 elements. What about number 9?
Oh, dang it. That one has 2.
Just 2 elements. What's number 8 have?
2.
2 elements. What's number 7 have?
3.
3. That's the trick. Good job, Autumn. That's the trick. So number 4 and number 7 have 3 elements. B, A, S, and O. I don't care about the subscript. I don't care about the 4s, the 2s, the 3s, whatever. Just look at the number of elements. 4 is BASO4, so B, A, S, and O. 7 has Na, C, and O. If you see 3 elements, you got to go to table E. That's the trick. You see 3 elements, you go to table E. Why do you need to know that? Because the back of your homework due tomorrow, okay, this side is naming these things. So you're going to have to start being able to use table E and then put them together and name. That's where we're headed.
What's due tomorrow? The other
This side is due tomorrow. Yeah, I'm going to explain that after this. So anyways, I'm trying to just help you out here with table E because it is a little confusing. All right, 11, MgO, Adriana.
Ionic.
Ionic, good. Metal, non-metal. All right. Here we go. Number 12, kicking the pants. Andrew. Lucky you. Well, it's either ionic, covalent, or both, so you got 33% chance of getting it right.
0.33 repeated.
Both! You're not wrong.
This is what we were arguing over.
Yeah.
This is actually ionic.
What?
Is it because
Now, there's only one reason I teach this, because I've seen the question twice. Now, I've been teaching for a little while now. So twice in 15 years is not very many questions, but a lot of kids got that wrong because I didn't address it. So now I really address it and make sure we understand. That's the only weird exception, actually not this. This is the only weird exception to that non-metal business, because there's no metals in 12. No metals. N and H are non-metal, Cl is a non-metal. There's no metals. But if you go to table E, it might help understand a little bit. Go to table E, look up NH4. What is the charge? +1. If you go to the periodic table, you don't have to. Go to periodic table, you see Cl is -1. Because this is positively charged, that's a cation, and this is negative, that's an anion, they use their ions to bond. That's what ionic bonding is all about, positive-negative attraction. So the reason that this is called ionic is because that's a positive ion. That's it. So NH4 kind of screws up the rule, metal, non-metal, but good news is it's the only one. There's no other exception. So if you see this in a compound, it's going to be ionic. It's going to be ionic. That's the weird exception. And I saw it on a reference or a Regents. It said, which of the following is an ionic compound? That was the choice.
So
I remember reading the choices, and I'm like, come on. And it was just, it's a low blow here to kids learning this stuff. So I got to at least go over it.
So anytime you see NH4, it's always ionic?
Yep, it doesn't matter what it's bonded to. This could be any other element. It's going to be ionic. It's going to be the ionic. So I wouldn't stress about that. If you understand metal, non-metal, two nonmetals, you know, ionic, covalent, then you're good to go. If you can't remember the one exception, I haven't seen it in a long time, but I have to address it. All right, 13, HCl. I'm going to kind of speed this up a little bit here. Actually, I don't know if I got a chance to call on everybody yet. 13, Jovan, I didn't call on you. Covalent, very good. Two nonmetals, H and Cl, covalent, good. 14, Caroline. Ionic. I hit everybody? Amanda, I didn't call on you? No, I didn't? All right, Amanda, 15.
15, the boat.
Both. NaOH, very good. NaOH, here we go, look up here. Metal, non-metal, two nonmetals, so that's both. Who knows the polyatomic ion? It's not Na. OH, what is it? Hydroxide, very good. NO2 is covalent. AlPO4 is both. Who can tell me the polyatomic ion in 17? Phosphate, PO4 minus 3, good. FeCl3 is ionic, P2O5 covalent, N2O3 covalent. Questions? What? You can. Well, all right. Yeah, you can pose. You got a little bit of time on it. You need this, don't you, Amber? All right, back to our notes now. Actually, before we go to our notes, let's go to the homework due tomorrow. Okay. Here's what you got to do. Underneath 32, 33, 34, 35, so right above the arrows, draw a line.
Wait, above what? Oh, above the arrow.
Above those arrows, draw a line. So 32, 33, underneath those, draw a line right across here. I'm just kind of separating the page. I didn't think of it till after I photocopied it. Sorry.
It's okay.
So draw a line under 32 through 36. Draw a line. Okay.
Wait,
Under
them or under them?
Under them. Under them.
Wait, you went through the
Like so.
You did
Okay.
right.
I didn't draw a line. I drew it.
Let me just make sure we got it here. Bear with me here.
Use your strength. That's what I said. It's not even even.
Okay, that's what I wanted. A line underneath those. Are we good?
Underneath?
Yes.
Wait, did I do that? I did it right.
Just like that. Just like that. Okay. All the ones above is what we're going to be doing for homework, except just the odd ones. So 7 through 35. 7 through 35, the odd, you can either write odd or circle the odd ones right now. Those are going to be due tomorrow. Now I'll explain what you're going to be doing. If you look at the top of the sheet, where you have 3 samples, you have water, ammonium ion, and sodium sulfate. Above the elements in each compound, you are labeling the charge that that element has. That's what you're doing on all the odd ones, 7 through 35.
Wait.
I'm going to do a couple with you. So first thing you need to learn, and please try and remember this, I will remind you a lot between now and June, but if you see one element like number 7, so if you see K, K is an element. It's a piece of metal. If you were to touch that piece of metal, you would be okay. Nothing would happen to you. The reason for that is it has a 0 oxidation number. It has a 0 charge. What does 0 mean? Neutral. All elements and compounds are neutral. I'm going to say that again. You already know this, but I'm going to say it again. All elements and compounds are neutral. So if you see an element by itself, you put a 0 over the top. So who can find the next one that gets a 0? AG, good. 27. Put a 0 above AG. It's neutral. It's an element by itself. You missed one, though. There's one before that. N2. Yes, put a 0 above it. That's a diatomic element. By itself, it gets a 0. I understand that. I understand it's even, but I was just trying to find single elements. Find another one.
I didn't even realize.
Find another one.
33.
S. S subscript 8. That's just, it's S, 8 atoms, but it's still S by itself. Just S, that's a 0. Okay. So that's the one thing that I really try to stress. You'll trust me, everyone will remember that by the end of the year. What?
About 31.
What's 31? What's going on there? Oh no, that's a compound.
That's 2 capitals.
It's 2 capitals, yeah. That's all right. Here's what I want you to do for the rest of them.
All compounds and elements are zero?
All compounds have 0, yes. So the total charge is 0. Let me explain. Go to number 8. I know you don't have to do it. That's why I'm doing it, so I don't ruin your fun. Okay. I want you to have as many practice as possible. Here's what I want you to do. You go to the question, whatever the compound is, now you go to your periodic table. You look up RB. What's the charge in the top right corner of the box for RB? Number 8. +1. So you label +1. Now you go to Cl. Look in the top right corner. What do you see? -1. Do me a favor. What's +1 plus -1? 0. The compound is neutral. Those charges cancel. We'll do one more. I'll do number 9 because I'm gracious.
Thank you.
Okay. How would we do this? What's the charge on Na? You go to the periodic table. What's the charge? +1. Find oxygen. -2. Now, look up here and listen carefully. That 2 throws kids off a little bit. They're like, wait, there's a 2 there. So I should put +2 there. Don't do that. Each Na is +1. You have 2 NAs and 1 oxygen. If each Na is +1 and O is -2, what does that add up to? 0. So that is +1, not +2. Kids get confused because they see the 2 and they change it. Don't change it. Whatever the charge is on the chart, that's what you put down. Ignore the subscripts. They matter, but they don't change the charge. The charge is what it is on the periodic table. Hopefully that makes some sense. So that's what I want you to do on all the odd ones due tomorrow. Okay? You're going to see some are more tricky than others. And remember, go to CL. Go to CL. Stop. I don't want you doing this right now. Go to CL. Look at CL. How many charges do you see? A whole bunch, right? What did I tell you about that?
First one.
Good. We used the first one. Guess what?
Use the last one.
Now we're going to use whatever one we need to. Hold it. Why would that change? You're using whatever one you need to make the compound neutral. So your pluses and minuses must add up to 0. So we're going to use this homework to learn that. So if you get confused, that's fine. We'll go over it tomorrow. Okay, so put that away. Back to the notes now. Here we go.
Do we still need a periodic table?
Yeah, keep your periodic table open. All right, so in our notes, let's put ionic over on the left side. Let's put covalent over on the right. I teach these 2 first. So I have a video that I'm going to show you right now. And in the video, it tells you the difference. So if you pay attention, you should be able to fill in your notes. Obviously, I'll go over it. I want to see if you can pick it up first. So lights, please. And if you're lucky, we have time, you can watch the music video as well.
No way. Wow. Yeah, we never have time in this.
True. Never have time to boil water either.
Bowl.
I don't know how to do that, but I can boil
Watch
water.
Water Bowl. I need to watch Water Bowl.
Sounds like a water bowl.
All right, don't pick on her.
A little late for that.
Embrace our differences.
It's like sloshing around.
Yeah.
Well, I said one thing. Everyone else is going at it. All right. Okay, here we go. No, I guess not. Still not here.
We got it.
So, listen up. It's going to tell you ionic, or it's going to show you and tell you what ionic is, show you and tell you what covalent is. It's a really good video. It's very, well, it's about 2 minutes, but it's short, to the point, and it's a good way to show the animation, because I can't show that kind of session. All right, so you're looking for how ionic bonds form, how covalent bonds form. You're going to write that down in your notes. You know, sometimes I just don't know what I'm doing up here. I had it set, and when I was making fun of her, I screwed up. That's what I get. Yeah. All right, here we go.
Ionic bonding occurs between 2 atoms when one of the atoms has sufficient strength of attraction to remove an electron from the other atom. A sodium atom has 1 valence electron, with a stable energy level below containing 8 electrons. A chlorine atom has 7 valence electrons. If the atoms collide with sufficient energy, the chlorine atom will remove the electron from the sodium. The sodium atom loses its only valence electron and becomes a positively charged sodium ion. The energy level below now provides sodium with its stable octet.
Will, are you with me?
The extra electron completes a stable octet for chlorine, which becomes a negatively charged chloride ion. Covalent bonding occurs when neither atom has sufficient strength to completely remove the other atom's electrons.
Okay, so let's review. What are you writing under ionic?
Occurs between two atoms.
Yes, it does. It occurs between
That's
two
all I
atoms.
got.
One has enough energy to pull an electron away from the other.
Right. You're both saying the same thing, a little differently. When one atom removes an electron from another atom. So that's what I want you to write. When one atom removes an electron from another atom. That's ionic bonding. When one atom removes an electron from another atom. Another way to write that, maybe an easier way, and that's fine, I want you to write that, but I want you to also put transfer electrons. That's what ionic bonding is all about. Transferring electrons. One atom gives its electron or loses its electron to another atom. Okay, I can give a ton of different analogies, but if this marker was an electron and I gave it to Jake, that's ionic. I just give him the electron. Here, take it. He takes it, and that's it. That's what ionic bonding is. One loses, one gains. Why is that advantageous? Why is that good? Here's why. Na has 1 valence. If it loses it, it gets 8. If it gives the 1 electron over here to Cl, Cl has 8. They both have a full valence shell. So they're both happy with that. Na wants to lose, Cl wants to gain, and that's what they showed you. So that's ionic. Metal, non-metal, that happens every time. Somebody loses, somebody gains. Covalent's different. Here we go. This one, these two atoms are both nonmetals, so they're similar in their attraction for electrons. I'm going to talk more about that tomorrow. So they can't give and take. So if you can't give and take, what's the alternative? Okay, let's say there's no stealing. You don't lose, you don't gain. What else could you do?
Transfer.
No, instead of transferring, we share. Sharing. That's it. If I have a pizza, okay, and I don't want to give you, Nick wants my pizza, okay? I don't want to give him my pizza. I want it for myself. If we were little kids, what would adults say? Share. That's what covalent bonding is. They share. So you can share. If you don't want to give, you don't want to take, you can share, and then you both win. Here we go.
The atoms share electrons, and both atoms achieve a stable outer energy level. A hydrogen atom with 1 valence electrons. The negatively charged chloride ion.
Watch the electrons.
Covalent bonding occurs when neither
They
atom
go back and forth between the two. That's kind of a good way to show the animation.
has sufficient strength to completely remove the other atom's electrons. The atoms share electrons, and both atoms achieve a stable outer energy level. A hydrogen atom with 1 valence electron needs 1 additional electron to complete the first energy level. An oxygen atom has 6 valence electrons and needs 2 additional electrons to complete the second energy level. As the oxygen and hydrogen atoms collide, covalent bonding is accomplished by the sharing of electrons. By sharing an electron pair with the oxygen, the hydrogen completes the noble gas configuration of helium. By sharing with the hydrogen atom, the oxygen atom now has 7 electrons in its energy level, still 1 short of the stable octet condition. A stable octet for oxygen can be completed by sharing an electron with another hydrogen atom.
So, covalent, what are we writing? Share electrons. So ionic, what do they do with their electrons? Give, take, or transfer. Okay? Ionic, they give, take, or transfer. Covalent, they share. Okay, we're going to say that over and over again. All right, I'll make you say it, or I can't literally make you, but I want you to say it, so if you say it enough, you get used to it, and you memorize it. So yeah, hydrogen and oxygen, remember this is water, so you need 2 H's, share those electrons. Therefore, hydrogen gets a full shell, like helium, 2, and then oxygen gets 8, and that's a full shell as well. So that's what covalent and ionic are all about, and how they're different. The only hard part about covalent is there's two types. We'll talk more about that down the road. But right now, all I need you to be able to do is tell me the difference between ionic and covalent. And that's it.
No music video.
Tomorrow, the music